Here we have a problem on logarithm. Okay, let's go to the question. If the logarithm of 324 to base a is 4, then find a. Okay, now let me write this expression as an equation. That is a logarithm of 324 to base a is equal to 4. Okay, so now in this equation, we have to solve for a. That is, we have to find the value of a that is at the base of the given logarithm. Okay, now but to solve for a in this equation, what I have to do is I have to convert this equation to exponential form. Already it's in logarithmic form. To solve for the base of this logarithm, so I have to convert this equation to exponential form. So how can we convert this equation to exponential form? For that, what we have to do is we have to consider the part which contains logarithm. So here the stuff on the left side of the equation contains logarithm. Now in this part, let me consider only the logarithm along with its base. So this one. So now to convert this equation to exponential form, I have to move the circled part to the right side of the equation. When I move this log with its base a to the right side of the equation, we have to ignore the logarithm. We have to consider only the base a on the right side of the equation. So what do we have to do with the value of 4 which already exists on the right side? So we have to make this 4 as the exponent of this base a. Now on the left side, we can write this value 324 as it is. So 324. Okay, now we have to solve for a. For that, what I'm going to do is I'm going to write this number 324 as a power with the exponent 4. When I write this number 324 as a power with the exponent 4, what we can do is we can compare this one and this one. So we'll be having the same exponent 4. So whenever two terms are equal with the same exponent, the bases can be equated using one-to-one property. Okay, now my aim is to write this number 324 as a power with the exponent 4. So for that, we have to decompose this 324 into its prime factor. Since it's an even number, what we can do is we can divide this one by 2. When I divide this one by 2, I'm getting 1, 6, 2. Again, we are getting an even number. We can divide this one by 2. When I do so, I'm getting 81. So 81 is not an even number, and also it's divisible by 3, because when I add the digits 8 and 1, I'm getting 9. 9 is a multiple of 3. So let me divide it by 3. When I divide 81 by 3, I'm getting 27. 27 is also a multiple of 3, so it can be divided by 3. When I divide it by 3, I'm getting 9. So 9 is a multiple of 3. Again, it can be divided by 3. I'm getting 3. So now 324 can be written as, so here we have 2 2s and 4 3s. So we can write as 2 to the second power times 3 to the fourth power. My aim is to write this number 324 as a power with the exponent 4. Okay, now let me consider the stuff over here. So here we have base 3 and the exponent is 4. So we don't have any trouble with this one because we got the exponent 4 over here. But the first one, the base is 2 and the exponent is also 2. But instead of 2, we need the exponent 4. For that, what I'm going to do is I consider the base 2 over here. Let me write the 2 over here. Now for this 2, I am taking square root. Then I'm getting square root of 2. So are 2 and square root of 2 equal? No, they are not equal. So but I have taken square root for this number over here. So to balance the square root, what I'm going to do is I'm going to take square for this number. Now, will this one be equal to this? Yes, it is, because the square root and square root I will cancel out. It's still equal to 2. Anyways, so we can write 2 as square root of 2 the whole square. So whenever there is an integer and if I want square root for that integer, so we can take square root, but to balance the square root we have to square. So that the stuff what we get on the right side is still equal to the original number 2. So now in this here, instead of the base 2 over here, we can write the square root of 2 the whole square. Let me do it. So 324 equals to, so for this 2, what we can write is a square root of 2, the whole square. Already we have exponent 2 for this 2, so the same exponent should be taken over here. For this 2, we have written this stuff, and this exponent is taken as it is, times 3 to the fourth power. Okay, 324 equals to, here the base is square root of 2, we have exponent 2, and for the complete stuff we have again exponent 2. Whenever we have two exponents like this, what we can do is we can multiply the two exponents. In that case, I'm getting square root of 2. 2 times 2 is fourth power times 3 to the fourth power. Here, two terms are multiplied with the same exponent 4. Whenever two terms are multiplied with the same exponent 4, what we can do is we can multiply the two bases and we can take the exponent 4 in common. So now let me multiply the two bases, 3 and square root of 2. So 3 times square root of 2, and we can take the exponent 4 in common. So finally, I got that 324 equals to 3 times square root of 2 raised to the fourth power. So now instead of 324, we can write 3 times square root of 2 to the fourth power equals to a to the fourth power. Okay, now let's consider the stuff on the left side, stuff on the right side. So both of them are equal with the same exponent 4. So whenever two terms are equal with the same exponent, we can equate the bases by one-to-one property. So when I equate the bases, I am getting 3 times square root of 2 equals to a. I got the value of a, so the value of a is 3 times square root of 2.